Hi, in this video we're going to look at a thing called the scalar product, also known as the dot product. Now, in the diagram here we have a situation of two position vectors A and B with the angle theta in between them. Now, we're going to apply the cosine rule over here in order to help us try and figure out what that angle theta is. So, in order to do that, we need to know the magnitude of A, the magnitude of B, and the magnitude of the displacement vector AB. Now, here we have the cosine rule. So if I say that side squared over there is going to be that side squared plus that side squared minus 2 times that side times that side times the cos of the angle between them. And if I rearrange that, I can get the formula that you'll most probably be recognize from the work that you've done on the cosine rule back in fifth form to look something like that. Now, we know that OA is the position vector little a, we know AB is a position vector little b, and we know that AB, the displacement vector, is going to be little a minus little b minus little a. So if I plug those into the formula, I can say, right, the cos of theta is simply going to be that statement over there. The magnitude of the position vector A squared plus the magnitude of the position vector B squared, and so on. Now, if I go and look at the component parts of this, A will have column format that looks like this, A1, A2, A3, and B has the component parts B1, B2, B3. And so I can work out my displacement vector B minus A, and I can work out the magnitude of B minus A. I can also work out the magnitude of B minus A squared. And when I go and expand all of that, then I have a statement for B minus A squared. Now you may want to go back, pause the video, go back and look at that last little bit of maths in more detail, but I'm not going to expand on that now. You can go and take your time to go and do that. We also know that the magnitude of A is simply going to be A1 squared plus A2 squared plus A3 squared, likewise with B. And so I can get this statement and I can plug it back into my formula. And that allows me to come up with this statement over here. The angle between A and B is simply going to be given as cos theta is going to be A1 times B1 plus A2 times B2 plus A3 times B3. So in other words, the x components added together, the y components multiplied together rather, and the z components multiplied together, divided by the magnitude of this vector and the magnitude of that vector. That gives us the angle between two vectors. Now, the scalar product of two vectors is written like this, A dot B, and is defined as being the magnitude of A, magnitude of B, cos of theta, where theta is the angle between them. Now, on that previous slide that I was working on, we got that statement to look like this. And if we rearrange this statement and bring the denominator over to the left-hand side, we will have the statement over here. And this is what is known as the dot product formula. We can either write it like that, or we can write it like that. And there we have the scalar product or the dot product for vectors. Now, this is going to be really useful. It's useful to work out the size of angles between vectors. It's also useful to work out if vectors are perpendicular to one another. And we'll look at some examples of those. So here's a very simple one, trying to find the angle between two position vectors. So I'm going to use that formula of cos theta is a1b1 plus a2b2 plus a3b3 divided by the magnitude of A and the magnitude of B. So I simply go and plug in my values that I have there from the components, simplify that down, get a ratio for the value of cos theta, and then calculate the angle. And I'm working here in degrees. Here are some slightly longer questions. Triangle ABC is defined by these 3 points. Find the angles in the triangle. So first of all, I'm going to draw my sketch. There were my 3 points in 3 dimensions. It's a rough sketch, so it doesn't have to be in any way accurate. To find the angle at A, this angle over here, we need to find the angle between the vectors AB and the vectors AC. So I need my displacement vector AB, I need my displacement vector AC, I'll also need the magnitudes of both of those. Plug those into my formula, and there I have the angle A, that angle over there. If I want to find the angle B, this is lying between the vectors now, it's lying between the vectors BA, not AB, but BA. Going that way, and that way. Those are my 2 vectors that I'm working with. So here are my 2 displacement vectors, and I can figure out my angle between them, and that angle is going to be 80 degrees. And finally, to get the angle at C, I need the vector CB and the vector CA. Got those 2, plug them into the formula, and there I have my 3 angles for that particular triangle. One of the really useful things of the scalar product is to help us figure out if vectors are perpendicular or not. So if we take a look at this situation, we've got our dot product, A dot B is equal to the magnitude of A times magnitude of A, B times the cos of the angle between them. If theta is 90 degrees, then over here I'm going to get the cos of 90 degrees. Now the cos of 90 degrees, you should remember from the work we've done with trig, is 0. So if it turns out that A dot B comes up as being 0, then we can say that the vectors are going to be perpendicular. So if I do this multiplication of the components of A and the components of B, and the sum comes up to being 0, then we know that those 2 vectors are in fact perpendicular, and that's going to be really useful. And here's an example. Work out if these 2 vectors are perpendicular. So I take the components of A and multiply them with the components of B and add them together, multiply all those together. There they are. They come to a combined total of 35, and so those 2 are not perpendicular. That allows me to test whether or not these vectors are perpendicular. We've got points A, B, and C, they're given. I want to show if triangle ABC is a right angled triangle, and try and find the size of the other 2 angles. So we're going to start out, we need to find the vectors AB, AC, and BC. I know that my vector AB, my displacement vector AB, is going to be position vector B minus position vector A. AC is going to be position vector C minus position vector A, and BC is going to be those 2 subtracted from one another. Now if I go and find the dot product of AB and AC, add them together, that comes up with a number of 26. So in other words, AB and AC are not perpendicular. I can work out the angle between them, because it's going to be a dot b over the magnitude of a divided by the magnitude of b, and that comes up as being a half, or cos of a half is 60 degrees. So I've got one angle. If I go and look at the dot product of AB and BC, here I do get the dot product to come up as being 0. So in other words, I know that AB and BC are perpendicular to one another. And finally, if I know that, and I know that angle A is equal to 60, I can say that angle C has to equal 30. In the next problem, they want you to find x, given that these two vectors, P and Q, are perpendicular to one another. If they're perpendicular, then you know that their dot product is going to equal 0. So all you need to do is to go and multiply together the appropriate components and then add them together. So 2 times x plus 1 times 7 plus minus 3 times 1. Though that sum of those products has to equal 0. So that gives me a little equation, which is easy enough to simplify down, and I get that x is equal to minus 2. So if x is equal to minus 2, then I know that these two vectors are going to be at right angles to each other. Right, what you need to do now is to go and find the homework exercise on my iMaths on scalar products and work on that, please. Thank you.